We know that Mars has an atmosphere. Uh, One of the first hints that it had an atmosphere was dust storms, seasonal variations, and ice caps. So I want to say some of these ice caps. The ice caps at the North and South Pole, kind of like Earth ice caps, you have some ice caps that are there, but the ice caps get too big in the wintertime. And so we in the summertime you still have a little bit of ice there, and then you have this residual permanent ice cap, and then in the wintertime it kind of goes away. The southern ice cap pretty much all goes away. The northern ice cap has a little small residual amount to it. Well, what happens here? Well, the permanent ice cap, the one that's always there, is, as you would expect, water ice, H2O. The rest of that ice cap is very interesting. Remember, the atmosphere is mostly carbon dioxide, but if you get cold enough, CO2 will freeze. And in the wintertime on Mars, it definitely gets below the freezing point of CO2. And so what happens is, in the wintertime, you start actually freezing the atmosphere itself. And so a whole bunch of that ice is actually dry ice, frozen carbon dioxide. Huge amounts of frozen carbon dioxide, hundreds of feet or more of frozen CO2. And so that's an enormous amount of the air that's actually being frozen out in the terms of the ice. So the ice caps get huge. In fact, the Viking spacecraft, when they were on the surface, they were showing pictures off in the distance right there. And as it got close to wintertime, then the Viking lander started showing frost and snow. Well, that was not water ice or snow. It was actually dry ice, frozen CO2. The atmosphere itself freezing out in the wintertime. And so that gives you an idea as to just how cold it gets on the surface of Mars. Well, that also explains something here. The Viking spacecraft, when they landed, they noticed the atmospheric pressure on Mars going through wild extremes. So we have these extremes in which, it reached a minimum, and then so I mean they're like freaking out because they started measuring the pressure, and the atmospheric pressure started dropping and dropping and dropping and dropping, and as it was dropping and dropping and dropping, then they had never seen anything like that before, pressure dropping that much, and then it turned around and started increasing, and so at its peak the pressure was like a third more than what it was at the bottom. And so they'd never seen it. We never see that on Earth. The difference in atmospheric pressure inside of a strong hurricane and outside is just like 3% difference or something. Like a 4% difference in pressure would give you a Category 5 tornado. So this is or an F5 tornado. So this is the idea that pressure in a planet could change by this much was totally startling. What was happening here? Well, what was happening was that the air was actually freezing. And so that explains something. So if you got Mars here, in the wintertime, you start freezing the air. Okay, well, in the meantime, the frozen air is sublimating up here. So in the dead of winter, you have frozen so much air in one hemisphere, you've dropped the pressure of the whole planet. And then as it starts warming up again, the atmospheric pressure starts increasing across the whole planet, and then it gets wintertime in the other hemisphere, and you start dropping the pressure again. Well, that as the air in one hemisphere sublimates and flows to the other hemisphere, that is what blows storms across the equator. No other planet does this. No other planet has storms that cross the equator like on Mars. On Mars, what's happening is it's simply that you're freezing the air on one side and releasing air on the other side, and you're literally blowing the storms across. Mars is weird. Okay. The ice caps tend to have some interesting things. The swirling air through there has carved little channels. Dust falls into the channels. When the sunlight hits the dust, then it warms the dust more than the surrounding ice, and that means it melts or sublimates the ice underneath and makes the channels deeper. And so the ice caps, particularly the northern ice cap there, seems to have these permanent little channels, spirally sort of channels that run through the ice cap. Mars also has incredible dune fields. Almost the entire northern half of the planet is like a giant smooth desert with dust dunes. I hesitate to call them sand dunes because as they blow around, the air is so thin it can't really blow huge sand particles, but it blows small particles, dust dunes. So the entire northern part is just these giant dunes sweeping around. So this is like an incredible half a planet desert of these dunes sweeping around all over the place. You know, I don't know if any of y'all saw the sci-fi movie Dune. Well, here it is on Mars. So the biggest dune field. These dunes sweep across craters and everything else. And so the northern hemisphere is dominated by these things. That's why there's very few craters in the northern hemisphere. They've simply been all covered up. The next question is, why are all these dunes there? Well, it's lower in the northern hemisphere than it is in the southern hemisphere, and so the dust tends to blow and accumulate there.